Hi all, this is Pallavi. Welcome to my YouTube channel. In my previous video, we have discussed about what is a central tendency and mean. If you have not watched that video, please refer to the link in the description. So in this video, we'll be covering about the other two measures, that is a median and mode, and also the relationship between them. So first, let us see what is median. So median is a middle value of a data set when the data set is arranged in ascending or the descending order. Let us consider two cases. The first, where the number of observation is odd, and the second case where there is even number of observation. So in the first case, in terms of odd number of observation, we have one single value. So this value is our median. Whereas in the even number of observation, we get two values in the center. So we take the average of these two values, which is our median. Let us consider an example. So imagine that a top running athletic in a typical 200-meter running session runs in the following time. So we have 7 observations. Now calculate the mean. So the first step is arrange the value in the ascending order. So here is a table which has the values, that is a timing taken in a ascending order. Since there is a 7 number of observation, we have a middle number, that is 4. So n is equal to 7. The middle number, that is a fourth term, gives a median. Now consider a case, the same athletic runs again and the time taken is 24.7 seconds. Now let us see what is the new median. Once again, arrange the values in the increasing order. So now the number of observation is increased by 1 and it changes to even number. So in center, we get two values. So the average of these two values, that is 25.2 and 25.6, gives a new median. So it is 24.4 seconds. Let's see how to compute median for the group data. This is slightly different from the previous steps. So we have a set of steps in which we need to compute the median for the group data. So first of all, prepare the frequency distribution table in such a way that the first column consists of the observation and the second is a respective frequency. So let us take this example. In this example, we have a middle value rather than having a range. So we need to convert this middle value uh, to the lower limit and the upper limit. So to do that, let us take a difference between these two middle value. So that is h. h is equal to 10, 15 minus 5, it's 10. To get the lower limit, we add middle value minus h by 2 and upper limit middle is got by adding middle value to h by 2. So we arrive at the class and we write the respective frequency here. And the second step is the third column consists of the cumulative frequency. So calculate the cumulative frequency for the given frequency. And then obtain n and find n by 2. The summation of frequency is n. So in this case, it is 100 and n by 2 is 50. Find the class whose cumulative frequency is just greater than the value n by 2. And this class is known as a median class. So n by 2 is 50. So we have 51, which is greater than 50. So this class is known as a median class. Now, using this formula, calculate the median. So we need a lower limit of the median class. So in this case, it is 30. L is equal to 30. F is equal to frequency of the median class. So we have 51. F is equal to 51. And the caps F, that's cumulative frequency of a class preceding the median class. So F is equal to 40. And we know N is 100 here. And H, that's the width of the median class. H is 10. So substituting all this value in the formula, we get median is equal to 31.96. Now let's see what is the properties of median. So median is not affected by any data value in the data set. And the individual value doesn't tell whether it is a median or not, but it's a position of that value which decides whether it is a median of the data set or not. And the distance between the median and the remaining value is less than distance between any 2 points in the data set. By adding or multiplying each observation with a constant, the median gets multiplied or increased by the constant value. Let's see what are the advantage and disadvantage of median. So median can be found looking at the histogram, and it is not impacted by the outlier. In an open-ended classes, we can still find the median, and it minimizes the total deviation. Coming to the disadvantage, median cannot be determined exactly for an even number of observation, wherein we take the average. That is nothing but the estimated value, and the value has to be arranged. So this is little tedious when it comes to large number of observation. And for the samples which is fluctuating, it will have an impact on the median. Next, let us look into the mode. So any value that has a highest frequency in the data set is known as a mode. Let us consider two cases, mode of a discrete series and mode of continuous series. So first let us consider an example. We have a marks and number of students having that mark. Let's follow some steps to get the mode. Arrange the value in a ascending or descending order and write the frequency of each value. The value that has the highest frequency is considered as mode. So in this case, 4 is the highest frequency. Hence, we consider 60 as a mode. Computation of mode in continuous series. Let's consider an example where we have a range of wages and number of workers belonging to that particular wages range. Let's substitute in the formula. L is a lower limit of the model class. In this example, 30 is a mode. So the lower limit of the model class is 15 and the frequency of a model class is 30. Frequency of the class preceding model class, in this case it is 15, and the frequency of the class succeeding model class is 20, and the class interval is 5. So substituting all this value in the formula, we get mode is equal to 18. Now let us look into the properties of mode. It is not affected by all observations in the data set. When it comes to the highly skewed or non-normal distribution, mode is the best choice because it gives a point of maximum concentration of the data. So in case of bimodal, that is two values having the same number of frequency, which is the highest in the data set, it is difficult to find the mode. In such case, we can go for an empirical rule, which is mode is equal to 3 into median minus 2 into mean. Let's see what are the advantage and disadvantage of mode. Once again, the mode need not be calculated. Just by looking at the histogram, we can make out which is a mode in the data set. It is not impacted by the outlier. Even in case of open-ended classes, we can still find the mode. Disadvantage of mode is that mode is not defined when there is no repeats in the data set. Sometimes in the data, we can have one mode or more than one mode or no mode at all. And it is affected by sampling fluctuations. Coming to the last topic, relationship between mean, median, and mode. To understand this, let us understand the distribution. First of all, let us look into the term skewness. So what is skewness? Skewness measures the asymmetry in a normal distribution. So distribution depends on the value of the skewness. First, let us consider the value which ranges between minus 0.5 to 0.5. So this is known as normal distribution or approximately symmetric. So in this case, we have all the three values, that is mean, median, and mode, equal. When the skewness is less than -1 or greater than 1, it is highly skewed. There are two cases, left skewed and right skewed. In left skewed, mode has the highest value and mean has the least value. In the right skewed, mean has the highest value and mode has the least value, and median is always in the center. Now let us consider a skewness value which ranges between -1 to minus 0.5 and also between 0.5 to 1. This is known as moderately skewed. In this case, we use Carl's Pearson formula, that is mode is equal to 3 into median minus 2 into mean. To test your understanding, please answer this quiz. Type your answer in the comment section. Don't forget to like, subscribe, and share my channel. Thank you.